Hello everyone, welcome back to the channel. I hope you guys are doing just amazing. In today's daily challenge on Leetcode, I will show you two approaches starting from O of n square to O of n log n. Okay, and I will also show you how the binary search on answer works. If you don't know it already, I will explain you in detail. So let's start. Uh, we have the minimize the maximum difference of pairs. You are given a zero indexed integer array nums and an integer p. You have to find p pairs of indices from nums such that the maximum difference among all the pairs is minimized. So you select p pairs of indices from the num, perform this operation nums I minus nums j for all the pairs I comma j, okay, and you perform this difference of absolute value, okay. You find which is the maximum among all my pairs, which is the maximum such absolute value. That value should be minimized. So if you take different pairs of p, that maximum value will be different and that maximum value should be minimized. Okay, so return the minimum maximum difference among all p pairs. We define the maximum of an empty set to be 0. So you can see the examples. Some of the examples are written. The first pair is formed by taking the indices 1 and 4, and the second pair is formed by taking indices 2 and 5. So they are taking 1 and 4 because they are both equal and they will give a difference of 0. Okay. So, and you have to select two pairs. Again, they are taking 2 and 3 because they will give a difference of just 1. Okay. So 0 and 1 among maximum of 0 and 1, we are trying to minimize this whole maximum value. So we are looking for small differences. Okay, to get a very small differences only, they use this, what to say, this O of this 1 and 1 to get a very small difference. To get the next small difference, they use this 2, that use this 2 as well as this 3, right? So that they get 1 0 and 1, and therefore we return 1. So similarly, they perform if you only one pair is required, you just select the equal number. Okay, that is only the maximum value. That is only the maximum. Now, if you see, look at the constraint, the nums dot length, the n is of 1e5. The integers in the nums is of 1e9, and p can also be the length or if of the order of 1e5 only because it's n by 2, so it's 1e5 only. Okay, so so if you have done binary search before, binary search on and answer before, this is a very standard problem of binary search. So I will show you how the binary search on answer works. Okay, uh, and why is I am calling it a standard problem, how you should recognize such problems, I will tell you. So let's just start quickly. I will show you the brute force approach first. So first you see as in this example 10 1 2 7 1 3. Okay, this example is there for 10 1 2 7 1 3. So we have the array 10 1 2 7 1 3. You see we are focusing on minimizing the max difference, right? Minimizing the max difference of p pairs. This is all we are focusing. So if we want to minimize the max difference, we should start with small differences, as I already explained you, right? So which is the smallest difference here? How will the smallest difference be created? If there are things which are equal, right? If there are things which are equal. So first thing, the first idea which comes is to sort the array. Why? Because if you sort them 1 1 2 3 7 and 10, you see the difference between that two adjacent element will always be the minimum. Why? Because uh, you see, if 2 and 3, this is arranged in the sorted order, right? So it is arranged in the increasing order. So the difference between the adjacent elements will definitely be less than the difference between some non-adjacent elements. Okay, for every adjacent elements, for every 2 comma 3, let's say, if you are telling that we select some adjacent element which is not adjacent to 2, we select some element which is not adjacent to 2, and take that the pair with 2, then always the difference will be maximum because it is arranged in sorted order, right? So So therefore, to get those minimum difference, the first idea which comes to mind is to sort the array. Okay. Now, what after sorting, what can be the brute force approach? Now you cannot say the first difference is always going to be the minimum. The difference can be anything, right? You can first get something like 1, 3, 1, 3, and you can get like 9, then again you get 9, then again you get 10. So yeah, the difference first is 2, then becomes 6, then becomes 0, then becomes 1. So difference can be anything. You can't say like first difference was only 0. So that is quite obvious anyways. So what to do? What to do? But it is always sure that the difference between an adjacent elements will always be the minimum one. The minimum one, okay? Difference between adjacent elements will always be the minimum one. So to find the first minimum pair, what you can do? You can traverse the array once. And find which is the minimum, which gives the minimum difference. So you can find the difference between all adjacent pairs. You see that difference is 0, this difference is 1, this difference is 1, this difference is 4, this is 3. Which is the minimum? 0. Okay, so if it is the minimum, I will select these two elements. Okay, I will select these two elements. So you got one pair. Okay, then you check for the next pair. You got the first pair already, you check for the second pair. Okay, second pair among these two, you will see that these two are getting tied. So see, this difference is no longer valid. So difference between 2 and 3 is already only valid. So you will go on like this. You will find here the pair 1, 1. In the second iteration, you will find the pair 2, 3. And in the pth iteration, so let's say you have a long array, you will find some I, j. Okay, not I, j, n of I, n of j, a of I, a of j. I mean to say that two elements you will get, and that will be only our maximum difference, because you are finding the minimum value among the remaining. Among all the remaining differences, this is the minimum one. This was the minimum one. Then after this got vanished, this is the minimum one. Then after this got vanished, and so on. The pth one is the minimum one. Okay, so this is the maximum one among the lot. Among the selected p pairs, this is the maximum one. Okay, because this is the pth minimum. This is first minimum, second minimum. This is the pth minimum, right? You need to select the pth minimum, which is nothing but the max among p. You can say this is nothing but max among p. Okay, so that is why you can apply such type of search. So if you see, what you are doing is that for every p, for all the p you are searching the array once, and for all the p, you are just going to the answer array once, right? So what you are doing, that n elements of the array, you are iterating p times. So order of n and p. Now p can be something like this. So it is nothing but order of O of n into n by 2. So it is nothing but order of n square complexity, which will not work here, which will give a TLE. Okay, you can go and check this out. I will not write this solution because it will give a TLE. You can understand. Okay. So how I was telling that this is a standard binary search question and stuffs like that. So I am assuming, so first of all, I am assuming that you already know the very basic binary search, which is something like you have an array, sorted array, you have an array sorted, and you want to find some element, you find a particular element from the array and you have to find it in log n time. I think you know this kind of binary search, so I'm not explaining that. Okay, I am assuming. If you don't know, you just go and check this. Very simple. This is the basics of DSA. You should know. Okay, but this I am trying to explain you why this kind of binary search means. So this is different. This is what we will use, is that binary search on answer. On answer. How to identify this kind of problem? So first of all, there can be many ways to identify. It's all depends on your practice. But one very standard method is there in today's problem. If in the problem it says find, not find, minimize. If it is something, it says minimize maximum value. Okay, something like this. If it is says, so you need to find some minimum of maximum of some value. If you are asked to find this, or if you are asked to find maximize some minimum value. maximize some minimum value. If you are asked to find something this way, maximum of minimum, then the first thing which should come to your mind is, by looking into the problem, is to apply the binary search on answer. Okay. Now, there are two methods. So bear with me. I will explain to you from the basics of what are these methods of doing. So there can be two ways of solving this binary search on answer. So, right. What you do exactly is that you take two limits. Okay. You take two limits. You just try to estimate that, let's say L, capital L, and limit, let's say capital R. Okay. You try to estimate that our answer, final answer, must be within these limits. Must be within these limits. Okay. You try to understand that the final answer must be within these limits. Okay. Now you try to this L, let's say this is L, the answer is somewhere here. Let's say this is R. Now, if you see something L is, let's say you find L to be something 0, R to be something 1 in 9, long range you find out. But if you try to find the answer in this, how much time it will take? It will take log of 1 in 9, right? So this is also very small. You can also do it. So there are two variations for this. Two variations which come. Okay. Binary search. You can remember how it's happening. In this problem, what exactly is happening, I will also explain you. Don't worry if you don't understand this portion, just don't worry. I'm just telling you. So what you do is, while L plus 1 less than R, you calculate int minima, int mid, same thing as you do in binary search. If you write an function which is good of M, that function must be a function of M. Then let's say you do L equal to M, else you do something like R equal to M. You do something like R equal to M. And what you do is, at the end of the while loop, you just return M, return L or R, whatever. So what is this exactly? What is this? So return L or R according to the problem statement. Okay. So if you see, there is another variation of this. Which has the exact same thing you need to do. So why I am telling this? Exact same thing you need to do. Sometimes what you need to do is that sometimes instead of this L equals to M, what you initialize is, let me delete this and delete this also. Instead of this L equals to M, you need to initialize R equals to M, and then L equals to M here. So how we will do this in this particular problem? What we will do? So this you can understand. I have just performed a binary search between L and R. Okay, I've just performed a binary search between L and R, and I am returning either L or R. I am returning either L or R. By seeing the problem, by understanding the problem, I will understand that which particular L or R I need to return, and what is this is good function. What does this is good function do? Okay, so what we will do now is understand the n log n solution of the problem in detail. In detail, we will understand the n log n solution. So the problem, if you see, you have a sorted array, right? As I told you here, you have this kind of sorted array. You have sorted the array. I already told you some intuition that how this sorted array, why this works, because you want to basically find the pth minimum, which is nothing but the max among p, which is minimum, p which is minimum. Okay, pth minimum difference. So you see, now you see this pth minimum difference will be somewhere in the array, and this will be my answer, right? This will be nothing but my answer, and I will apply binary search on this. I will apply the binary search on this. So you see what can be the minimum and maximum difference. So since it is called absolute difference, I can easily understand that, as I told you, that my L value will be nothing but 0. The absolute difference is 0. So for safety, we take one less than the maximum value. Okay, for safety, I do it personally, because many times I get confused with this thing, and I've seen that in general it works. In general it works, taking one less than the left value, because you are doing the binary search and ultimately you will arrive at your answer. There's no problem about that. And what is the maximum possible difference you can generate? So it is the first term of the array minus the last term. That is the maximum possible difference you can generate. You cannot possibly generate. So I take just one more than this. I take one less than this L and one more than this L as my L upper and lower limit. And I say that my answer must lie in this. Answer lies in this. Okay. Okay. Now you see. I perform a binary search in this, as I told you, in this L and R. While L plus 1 is less than R, I will do some int m, which will be L plus R by 2, which is nothing but L plus R by 2. Okay. And I will do an isGood function. Now, what is this isGood function in this case? Okay. I will check whether m is good or not. What do I mean by this? When I say that, I will check whether m is good or not. Okay. Now, this it is good. This whole thing is happening in log time, right? Log of n time. So you have the freedom to do a linear time search on this isGood function. Okay. So how will you define this isGood function here is that you go through the array. You try to visualize. You go through the array. Okay. You go through the array and you check how many such differences is there which is less than m. Okay. So you see, what do I need to do here? I need to make this as the maximum difference. Okay. So if I am able to select p pairs, if I am able to select p pairs, select at least p pairs from array, if I am able to select at least p pairs from array whose absolute difference is nothing but less than equal to p, less than equal to m. Okay. So what does this mean? Select at least p pairs from array whose absolute value is less than equal to min. Absolute difference is less than equal to m. Okay. So this means that m is the maximum difference. And I am compressing the difference more and more. I am compressing. What do I mean by getting compressed? You see, whenever you try to do binary search, this isGood function is always, in these kinds of binary search, is of something like 0, 0, 0. The function, I'm writing the function, right? It is binary function, right? So it will have the output either this in this fashion or in this fashion. You must try to write the output in this way. Okay. Now, what do I mean by this? Now you see, if I select a very large value of m, if there is the m value is very large, if it is very, very large, you will very easily be able to select p pairs whose difference is less than equal to m. Okay. We will is very easily be, because if you are having a very large value somewhere here, then the output is 1. It means that my m is good. Okay. But if you are having very small value and you want p pairs of difference still smaller than that, then it is 0. So you recognize that this function is of type this. Okay. This isGood function is nothing but of type 0, 0, 0, 1, 1, 1. So what I need to find is the transition point. This is the transition point of this 0 to 1. The transition point is of this 0 to 1 and this thing. Okay. So I start with L here and R here. If I get isGood of 1, if I get, these are 2 pointers, right? First and last. If I get isGood of L plus R, middle is somewhere, let's say here. If I get it to be 1, I will shift my R pointer. To M. So here we do shift my r pointer to m. Otherwise, if it is 0, if my middle somewhere comes out to be 0, I will shift my L pointer. Else, I will shift my L pointer to be m. Okay. And at the end, I want something which gives me the value of 1, right? Because at the end, I need to be able to find p pairs, but I want to find the optimal such p pair. I want to find the optimal such p pair. Okay. So I will just return r. Return r. Why I am returning r? Because this 0 1 as the in this 0 1 intersection, in this 0 1 intersection, this will nothing come out to be nothing but L. This will come out nothing but to be R. So if you think I am speaking a lot of irrelevant things, something like this 0 0 0 1 1 1, what is all this? So you understand that this is nothing but the general method to perform binary search on answer. General method to perform binary search on answer. Okay. This is nothing but the general method which I am telling you. Uh, in in this portion only, I should have told you that this is good function always whenever you perform this is of type 0 0 0 1 1 1, and you want to find this intersection, or it is of order 1 1 1 0 0 0, and you want to find this intersection, whether you need L or R, whichever you need to return the answer, that depends on the problem statement. See, as in this problem statement, I need to select p pairs. So this good functions. Okay, so what does this is nothing but the statement of is good function, right? Is good. Is my m good? The If you are able to select p pairs from array whose difference is less than equal to m, then only my m is good. It means that my m is maximum among those p pairs, and that must be the minimum. That means that it must be the it I should get one, that I should get one result. It is good means I should get one result, but that one result should be minimum possible. That one result should be minimum possible. Okay, that one result should be minimum possible, and that's why I need to select the leftmost one. Nothing but select the leftmost one. Okay, and after performing binary search, this r will be converged to 1. Okay, so if you are doing this for the first time, maybe it's maybe difficult for you, but you do a lot of practice. There is a binary search Leetcode. You go to study plan, there is some binary search playlist also. You can just try to do that playlist. Things will get very easier to you. So as we will code also, we will try to understand things, and definitely you can ask me in the comment section if you are doubtful. So let's just try to code. Let's just try to code. Once you get to know these kinds of binary search, this is a very standard problem, and you can just code it in like just 5 minutes. You can just code it, because this minimum of maximum, whenever it is asked to fund you, in 95% of the cases, 95% of the cases, you just need to apply binary search blindly. Nothing else. Nothing else you need to do. Okay. So as I told you, let's have an n value. Okay. What I will do, what I am proposing to do is binary search on answer. Okay. Now, I have something like this integer left pointer, which is nothing but -1. I will initialize to, as I told you. R will be nothing. So first I will sort, right? First I will sort the array. So for binary search, I am not sorting the array. Mind it. Here I am sorting the array because I realize that adjacent elements will be minimum possible. Then the non-adjacent elements, the difference between them will be minimum possible. Okay. Now you have this. And R is now nothing but nums of n minus 1 minus nums of 0 plus 1. Okay, just initialize it. As I told you, the template for the binary search, you can just keep it in your mind. While L plus 1 is less than R, what you do int m equals to L plus R by 2. Okay, and you perform if is good of m, right? You need to pass m, but you also you need the vector, right? You need the vector nums, you need m, you need p also, right? You need to check whether that is p or not. Else you do something and you return also something. I will explain you now. this should be a bool is good function. This is nothing but a bool is good function, which will give you a vector, of nums, and it will have integer m and integer p. So this function returns uh, this function. First of all, it will count how many such pairs are possible whose difference is greater than less than, sorry, is whose difference is less than. Why I need to make m as the largest, right? M as the largest, so all other differences should be less than m. Okay, this function count first of all, and this count must be greater than or equal to p. Okay, you need at least p count. So that you can say that, yeah, I can select some numbers. I can just, if I am some count which is greater than p, I will select p of them and say that m is definitely larger than all of my p. Okay, so I have this count. Really simple. You perform a greedy operation from starting from 0 to n. Okay, what you do is that if you see, not n, we will go till 1. If you see, if it's already sorted, right, nums is already sorted. So if you see this I plus 1 minus nums of I, if this is uh, less than or equal to m, you just count plus plus. And since you have selected these two indices, you can select. So I am, as I am telling you that, since you have selected these two indices, so if you are selecting, let's say you have some a, b, c, d, you can form the pairs b, c, c, d. You can form it, right? But if you select bc, you cannot select cd anymore. So if you are selecting difference bc, BC means you can't select BD, you can't select BD, CD, right? You can't select CD. So you need to jump one index. So that's what I will be doing here. I will jump one index because I am already selected this. It is always optimal to select. If you don't select and move on, you don't think that this is something like select or don't select type of thing. If you don't select and move on, you will always be at a loss. Because you are not selecting something which is less than this m, and so you are losing one value. Even if you move to the next one, the remaining n will never be selected because you have already moved past it. Okay. Else nothing. Okay, so if you see something is greater, you just skip one index. So skip index. You skip index because you are selecting a pair, right? You have selected a pair. So pair definitely means there is one more index with it. So you cannot select that one more index. Now you need to return for false. This count must be greater than equal to p, as I told you. So this count must be greater than or equal to p. If it is there, then only it is possible to select p pairs, and in that p pair, all of this p pair, the m is greater. P pairs all with all difference less than or equal to m, then only it is possible to select, right? Okay, as I told you, if you select a very large value of m, okay, if you are select a very large value of m, you will easily get something. You will easily get this is good function. You will easily get a lot of count. So you need to shift the right pointer. M, else you just shift the left pointer m. Okay, and you return r because it is of the type 0 0 0 1 1 1, and you are at somewhere here. L is 0, R is 1, and you need something which is still good, which is still valid, but you need to find the minimum possible maximum. So find the leftmost one. This This function ensures. So why minimum of maximum? You should apply the binary search. This function ensures Maxwell. Okay. Now selecting this leftmost one ensures mean of Maxwell. Mean of Maxwell. Okay. That's why mean of Maxwell or max of Maxwell. These things you need to do it by binary search. Okay. I have tried my best to explain you. If you still have some doubt, you just comment in the comment section. I think it's okay. I think it's okay. So let's just try to submit and check if it works. We don't have n here. We just calculate n then. Yeah. Just calculate n here. Let's try to submit now. The spelling of nums is wrong. Spelling of nums is wrong again. I missed a semicolon again. Any mistakes? Okay, we do have the accepted thing. Let's try to submit it. So see, we do have the accepted thing. We have an okay runtime complexity this time. The solution is definitely n log n, as I already explained you. Yeah, so this while operation is doing a log n, and this is good is doing an O of n operation. So that's n log n. That's all. That's all for this problem. This is a very standard problem, medium problem. If you know the technique, and if you don't know, it might look difficult to you, but it's not that difficult to understand, I think. So this was a medium problem for today, and I hope your day is going to be really easy. If you have not followed my channel, then definitely do subscribe it. I have now like launched a playlist of DP, and I am going to teach DP from the very basics to advanced level, which comes in the placements. I will also discuss some problems which are being recently asked in the interviews of all kinds of companies. So yeah, that's all. That's all for today. I hope you have an easy day ahead. Thank you so much.